Hello everyone. Welcome again to another episode of physics. Alright? Solving practical problems, mechanics problems, real life problems, applying equations in physics, simplifying physics for students to understand and relate real life problems with equations. Alright, now we have this question on the board. Still on mechanics. Two particles, X and Y, starting from rest. Okay, so we have two particles. Take note, two particles. So let's call it the section for X and the section for Y. They started from rest. So their initial velocities ux 0, uy 0. Their initial velocity is 0. They started from rest. According to first law of inertia, Newton's first law of motion. Alright? Now, they cover the same distance. The same distance. So let's say the same distance Sx, let's call it S. The same distance Sy, let's also call it S. They cover the same distance. Follow me step by step. Alright. Now the acceleration of X is twice that of Y. So the acceleration of X. So we have acceleration of X, acceleration of Y. So let's call the acceleration of Y, let's call it A. Alright, since we are told that the acceleration of X is twice, 2 times that of Y. So AX will be what? 2A, 2 times A. Follow me step by step. Now the acceleration of X is twice that of Y. Find the ratio of the time taken by X to the time taken by Y. Follow me. So the time taken by X, we don't know. The time taken by Y, we also don't know. But we're going to express them as a ratio. Express the time taken by X as a ratio of the time taken by Y. Now let's go on. We have USAT, equations of motion. I recall them again. V plus U over 2 times T. V equals to U plus AT. S equals to UT plus half AT squared. And then V squared equals to U squared plus 2AS. Please note it down. So which of the four equations contain U, S, A, and T? Obviously this one, which is S equals UT plus half AT squared. Now, okay, so what do? Since the distance is the same, so let's say this is the distance for X, and this is the distance for Y, plus half AT squared. So for X, I'm going to have UX here, TX, so that we know that this is for X. Then AX, TX, okay? So subscript X. So then for Y, we have UY, TY, AY, TY squared. Alright? Since the distance of X is the same as Y, since Sx is equals to Sy, we're going to equate these two. But before we do that, Ux is 0, Uy is 0. So this is 0, this is 0. 0 times any value is 0. So this goes off, this goes off. We'll settle that in our minds. Alright? So we have what's remaining for X? Half Ax Cx squared equals for Y half AY CY squared. So half, and think of half. Now what is remaining? AX, what is AX? 2A times TX. We don't know, so we have TX squared. What is AY? A. And we also have times TY squared. So A divide A, right? So what's remaining? We want to express the time taken by X, TX, as a ratio of Ty. So Tx over Ty. So what do we have here? So if I divide both sides by Ty squared, divide both sides by Ty squared. So what do I have? Okay. What do I have? Let's finish up from here. Okay. So what do we have? We're going to be having, finish up from here. We're going to be having over ty squared equals 1. We have nothing here remaining. 1. So what do we have from here? We divide both sides by 2 because what we need is tx over ty. So 2 times 2, you have 1. Then you have tx squared over ty squared equals to half. Now, half is in the options. It's among the options, but we don't need tx squared over ty squared. All we are looking for is tx, the time for x over the time for y. So how do we get tx and ty? We'll take the square root of both sides. And when we do that, we're going to be having tx over ty. Square root, pull out square root. Then we have equals to square root of 1 over square root of 2. Square root of 1 is 1 over square root of 2. If you want to leave your answer in decimal, square root of 2 is 0.707. Alright? So our answer is 1 over square root of 2, which is option C. So we have expressed the time taken by a particle x, ratio time taken by a particle y, and the answer is 1 over root 2. Alright, please like and share and follow for more videos.